Okay, guys, this week we are doing coordinate geometry. So we're going to try something a little different. Instead of using the slides, which I will put up on our Google Classroom, I'm going to use the written notes, and that's what you guys will be submitting. Hopefully that'll make it a little bit easier for you. That way you can just type in, you don't have to worry about moving things around, since a lot of us are having struggles. If you are someone who likes the interactive notebook, you can go ahead and email me and I will send you that instead in order for you to use that. So basically here we are. So we're going to do coordinate geometry that's on a plane. So when we start, instead of writing out the definitions, I'm just going to draw pictures for you, and then you will be able to look at the written definitions through the notes, which you should be reading before you're doing the assignments. So we know our graphs look like a T. Our x-axis is the axis that goes across this way. This is our x-axis, okay? Left to right. Our y-axis is up to down, okay? And that is our y-axis. Your coordinate plane is your entire graph. So this entire thing, this being x, this being y, the whole thing is your coordinate plane. An x coordinate is your value of x, and when it's written, it will be x, comma, y. So in this example, if you had 2, 4, 2 is your x coordinate. Same thing, you have x, comma, y, 2, 4, 4 equals your y coordinate. And then an ordered pair is your entire xy set. So x dash y is a coordinate pair, both of them. You always have an x and a y. So now we're going to scoot over page 2. So we have our origin. Your origin is the center where your x and your y cross. So here's your x, y axis, right? X, y, where your coordinate plane. You have x and y right here. That's your origin. Your point of origin is always going to be 0, comma, 0. Okay. So when we talk about quadrants, there are 4 quadrants in a coordinate plane. Here's your coordinate plane. Your quadrants count counterclockwise, starting with the top right. So you quadrant 1, 2, 3, and 4. So remember, they go counterclockwise, starting with top right. And then we have distance. We all know what distance means, right? It's the number of, or the unit of measure between 2 points. So if you were to have a coordinate plane like so, and you have a triangle drawn, your distance is from this point to this point, okay? This is your distance that they want to know. And then you have your midpoint, which is the halfway point between on a line between two. So if I have this line right here, and obviously here I'm guesstimating, this would be approximately my midpoint, okay? Okay, on to the next page. So we have what are points, right? So this is the concept. Oh, I think I skipped one. I did. Before we do what are points, we want to do what is the coordinate plane, right? So the coordinate plane can be used or thought of as two number lines, one number line that is horizontal, one number line that is vertical. Remember, horizontal goes this way, vertical goes up and down. They make a grid. In other words, the coordinate plane is a grid with these two axes at right angles. Positive x is to the right, negative x is to the left, positive y is up, and negative y is down. So how do you locate x equals 3 on a number line? Well, you start at 0 and you're going to count 3 over. You can locate y equals 5 on a number line by starting at 0 and counting 5 up. So here's my coordinate plane, right? We have x equals 3 and y equals. So starting at my 0, 0, 1, 2, 3. Here's x equals 3. And then y equals 5. 1, 2, 3, 4, 5. Easy enough, right? You guys know how to plot your points. So on to what are my points? So here, on a single number line, there's only one point at which x equals 3. In the coordinate plane, there's an infinite number of points with an x coordinate of 3. So we know this, right? Because you could have x equals 3, y equals 1, x equals 3, y equals 2. So you have all your y options on that line of x. So basically, what you want to remember is that when you're locating a point, you want to think about an ordered pair, x, y. It's naming the intersection of the 2 points, right? So here is, let's see, can I add an object? Okay, so I'm just going to draw it. So we have coordinate plane, right? There's my coordinate plane. X and Y. Okay, So here, if we were to use x is 3, and draw with a blue line, any point on this blue line would be x equals 3, okay? Any point. So we'll make this a little dotted line, just so we remember it's not a line. Anything on that line would be x equals 3. Anything on the orange line would be 3, 4, 5. Y equals 5, okay? Your intersection, your actual ordered point is going to be right here. This is point 3, 5. But anything on those lines could be the 3, and everything on the orange line could be the 5, okay? So you just need to remember those things. So what's an example of a point and a line related to coordinate planes, right? So your line could be multiple different options. You could have x-axis, right? That's a line. The y-axis, that's a line. You could also have x equals 3 or y equals 5. Those are lines. But a point has to have an x and a y. So you have origin, which we know is 0, 0. You can have 3, 5 is a point. Negative 2, 7 is a point. Or you have your midpoint. Okay? So now, one more concept. So when we are using a zero value coordinate, everywhere on the x-axis, the y-coordinate is 0. The points are in the form of x0. In other words, the x-axis line is the line when y equals 0. Everywhere on the y-axis, the x-coordinate is 0. The points of the form would be 0, y. In other words, the y-axis is in the line x equals 0. So this is the most common error in plotting a point such as 0, 2. The x offset is 0. Your pencil moves 0 units in the horizontal direction and then only up 2 units. Many students draw 2, 0 instead. Hashtag fake news. So yeah, I'm that person. I like hashtags. But anyway, so when we go about doing this, we want to look at the concept, right? So if we have the point, I'm just going to make up a random one, 4, 0, 4, 0, 4. Remember, your x comes first. So for this one, we're going to just count 4 to the right. 0, 1, 2, 3, 4. Okay, so this would be my 4, 0. The 0 means I am not moving up or down. With this one, I'm starting at 0 and I'm just moving up 4. 1, 2, 3, 4. So this one will be 0, 4. Notice I didn't move left or right. I only moved up. Make sure you remember that. So for your skill practice. You are plotting points for your first skill and your second skill. On your third skill, it wants you to show a point in quadrant 2 that is actually, we'll do concept C first. So, for concept C, it says, you have noticed that two axes divide the infinite coordinate plane into 4 pieces. We call those quadrants, right? We talked about this already. The important things to know about these quadrants are quadrant 1. Both quadrants are positive. I don't care what you do to remember this, but make sure you remember these things. Quadrant 1, both things are positive. In quadrant 2, x is negative because now we're at the top left, and y is positive. In quadrant 4, both are negative. So think about it. We start at the top right, now we're at the top left, now we're at the bottom left. Both are negative. And then quadrant 5, you have a positive x, but a negative y. Okay? So just as a reminder, I'm going to draw you another picture of your quadrants. So here's your axis. You have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Both positive. X negative, Y positive. Both negative. And then here you have X is positive, Y is negative. Okay, so those are the things that are important for you to remember. So, a point in quadrant 2 is reflected across the y-axis. What are the signs of the resulting xy coordinate? So, basically what this is saying, sounds complicated. It's not, I promise. So if I have my quadrants, right, and I'm starting in quadrant 2, and it's reflected over the y-axis, so we know this is y right here. So this is the line that we're going to reflect over. When we go from here to here, what is changing? What sign is changing? So here we have a negative sign. Here we have a positive sign. Both signs will be changing. So, one more concept. Distance on the number line. Nobody really likes distance, but we gotta do it, right? So, you have options. When you're using a number line, you can just count. You don't necessarily need to use the distance formula, but we also like to know both, right? So we will get to that. So when you're talking about distance on the number line, you are talking about a physical number line. Here's my line. Start at -5. Right, so there's my number line, -5 to 5. If you were to travel 2 miles from home to school on the way home, you do not travel negative 2 miles, you travel another 2 miles, right? So home is 0 miles. You're traveling 2 miles to school, and then you're traveling 2 miles home to get a total of 4 miles. That is your distance. Distances are always positive. See, always positive. You can very easily find distance between 2 points when either the x or the y coordinates are the same. You are able to count boxes on grid lines or grid lines, right? So when we're doing it on a coordinate plane, you can do the same thing. You're still just counting, right? It's if we have 3, 2, and 9, 2. Our y's are the same. So you're just counting your x's. 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9. You will have 6 spots. Your distance will be 6. If you were not to just count up and you wanted to physically show the work, you need to make sure that if you're subtracting the largest number from the smallest number, right? So in this case, 9 minus 3 equals 6. Or you can use your absolute value signs and do 3 minus 9 equals the absolute value of negative 6, which really equals 6 because we know that a negative and an absolute value sign does not matter. Okay? So, okay. So, you have two options here. You can find the distance in a coordinate plane by using the Pythagorean theorem, which means that if you have a plotted point, right? So I say we have a point here and a point here, and you turn this into a right triangle, you can figure out this distance because we know that a squared plus b squared equals c squared. C squared will be your answer. So the 2 points we're going to use here will be negative 3, 5, and this one will do negative 5, 1. Okay, those are my points. So if this is negative 5, 1, this point from here to here, and that's negative 3, we know that's the distance of 2. So this is going to be our A. So to get A, we did negative 5 minus negative 3 in our absolute value because obviously distance is always positive, right? The negative 5 minus negative 3 would be negative 2, which really just equals 2. So we go from 1 to 5, we can do that in our head, that's 4. So we have 4 squared equals c squared. 2 squared is 4. 4 squared is 16. C squared, 20 squared, 20 equals c squared. Square root of 20, square root of c squared would get you c equals. Is 20 a perfect square? Nope. Nope, it is not. So c equals radical 20. You would be able to leave it like that. On yours, you would get more easy answers, but I just did that in my head. So then your second option is to use the distance formula. The distance formula, you can see right down here, is the square root of x1 minus x2 squared plus y1 minus y2 squared. So if we have 1, 5 and 3, 7, I want to find the distance between those 2 points. This is my x1, my x2, my y1, my y2. Okay? So 1 minus 3 squared plus 5 minus 7 squared. We're going to end up with a number that doesn't work. So actually, I'm going to do this backwards. We're going to do 5, 7, and 1. Make a nice easy numbers for this. So same thing. X1, X2, Y1, Y2. Put our square root. 5 minus 1 squared plus 7 minus 4 squared equals. Bring it down. 5 minus 1 is 4. 4 squared. 7 minus 4 is 3. We have 3 squared. All under my square root. 4 squared is 16. 3 squared is 9. You have 16 plus 9, which is 25. The square root of 25 is 5, because 5 times 5 is 25, which means it is a perfect square. So those are your options. You can use either or. For this skills practice, my paper, but not yours. You can use either formula, okay? And the midpoint. You can do that one on your own as well, okay? One. So, finding the midpoint. There is a midpoint formula. This is the formula you need to know. It is very important. So, you have x1 plus x2 divided by 2 is your first point. That will be your new x point. And then you have y1 plus y2 divided by 2. That will be your new y point. So if you have the point 1, 5, 2, 3, 3, 1. Okay. So x1, y1, x2, y2. Fill in your formula. 1 plus 3 divided by 2, comma, 5 plus 1 divided by 2. And then this whole thing is your point. 1 plus 3 is 4. 4 divided by 2. 5 plus 1 is 6. 6 divided by 2. Your midpoint is 2, comma, 3. Easy peasy lemon squeezy. If you guys have any questions, please feel free to email me. Okay. I also will be on the WebEx at 11 if you need any help. Have a wonderful day.